Okay, this video is to help anyone that's struggling with the experimental design boxes. This is the second video, experimental design box in your lab book. I don't know what page it's on, but it's about Jake. Jake has a pretty cool problem if he's in high school, and that's that he has a hot tub, and he wants to put water sealant on the wood around the hot tub on the deck. And he wants to put the best kind, obviously, not waste his money. So he's going to test what type of a water sealant works best to seal the water out. So go ahead and read this with me. It says, Jake's family had recently built a new deck for a hot tub. He wondered which brand of water sealant would best protect the wood decking from absorbing water splashed from the hot tub. Jake performed a test by cutting small blocks from the decking material. He dipped 2 blocks in each one of 3 major brands of sealant and allowed it to dry for 2 days. He masked each block. Jace placed the blocks in hot tub water overnight. He masked each block again, finding the difference in the masses in grams. He concluded the difference was the amount of water absorbed. So this is a pretty good little experiment. All right, so let's go ahead and let's look for these as we go along. And I have them all over here typed out because I tried to start drawing this and my writing's terrible. But the first thing that we want to identify is the problem. And remember that the problem is what we want to know. So it's really what Jake wants to know. And if you look right above Jake's name, you will see what he wants to know. It's right there in the scenario title. It's the effectiveness of water sealant. All right, so I've put it a little bit different when I wrote it over here. And this, which brand of water sealant works best? So that's really his question here. Which of these brands is going to protect my deck the longest? Okay, I got interrupted there and had to pause and I don't remember where I am. But just realize the problem is always what we want to know, and it's almost always in the scenario title. So that's pretty easy. Now, this one sometimes confuses kids because when it gets to possible hypothesis, usually I tell you the name of the stuff that you're dealing with as far as the brands, but I don't really say. So what I'm going to say for mine, and you do not have to put this, is that all brands are the exact same. Now, in here, like I said before, nowhere in here does it define what the brands are. So when I get down to my IV and my treatments, I've just made up names for those. So possible hypothesis, all brands work the same. My independent variable, remember that the IV or independent variable is the thing in the, hold on, my kid's coming. All right, got interrupted again.
What was that?
I'm just making a movie for my kids. All right, you can hear my son Jace in the background. Do you want to say hi?
No.
Okay, that's okay. He's a little bit sad. All right, so let's move to the IV, which I was saying is what I change. So if I put myself in this story, I'm Jake. The thing that I'm going to change is right here, the brand of water sealant. All right, my little boy was convinced I was going to turn to Jake. All right, so his IV, the thing I would change, is the brand of sealant. There are no units for the brand of sealant since it's not a measured thing. Now the treatments are the way I change the IV, or I change the brand. All right, and there is no brand listed, so I just made up the names. So I have brand A, I have brand A, brand B, and brand C. I did that out of order. All right. So, and you can make up whatever you want. You could say Davidson, brand Rules, brand The World. You can put whatever you want. Now, when you read this, you will see that the number of trials is actually stated. He said he dipped 2 blocks in each. So the amount of times that he repeated this is 2 for each brand. So let's go ahead and pull those over. All right, now, for some reason it won't pull that one. There we go. Now, the dependent variable. The dependent variable is always the one that we measure. All right, so if you look in the sentence for something he measured, it said he massed each block again to find the difference in the masses. He concluded the difference was the amount of water absorbed. All right, so it's the amount of water absorbed. Now there is a unit for this. It tells us right there that it's grams. So I'll go ahead and put that in there. And then we need to worry about the constants. The constants are the things that have to remain the same in order for this to be a valid experiment. Now there's lots of them. That's why I put the dots right here. But 3 of them that just came to mind and are important are the material used. Obviously it should be the same decking material. And you could say like size and shape and all that, just as material. And the soaking and the drying times for each block. And then over here again I wrote the size of the block. So there's a lot more things he could keep constant. On your test when you're asked to find constants, name at least 3. And then finally you can always answer this the exact same way. What are the ways the experiment may have been improved? More trials. All right, if you want to write more than that, he could do different types of wood to see if it was consistent, but that not necessary since this deck is one wood. You could put other brands. You could say soak and dry longer. You could do whatever you want, but essentially the number one way to increase accuracy is to do things more than once. All right, I hope this has helped you a little bit. I know it's really ugly to look at, but hopefully it made sense.